Dear students, in this video I have come up with chapter number 7 back exercises, that is physics chapter 1. The name of the chapter is motion. So first let's come to question number 1. That is, an athlete completes one round of a circular track of diameter 200 meter in 40 seconds. What will be the distance covered and displacement at the end of 2 minutes 20 seconds? So let's first draw the diagram for this. We will draw a circular path and the diameter given is between A and B. We'll name it as AB as a diameter, and this is given as 200 meter. So obviously firstly we'll find the radius. So radius will be equal to the half of diameter, that is equal to 200 divided by 2, that is equal to 100 meter. Now the time taken to complete one round has been given. Time taken to complete one round is equal to 40 seconds is given, and total time that has been given is equal to 2 minutes 20 seconds. So first we'll convert that 2 minute 20 seconds into seconds. So that will come out to be 2 into 60 plus 20. That will be 120 plus 20. That will be equal to 140 seconds. Now first we will find the circumference of the circular track. So circumference is equal to 2 pi r. That is equal to 2 into 22 by 7 into radius is 100. And that will come out to be 4400 divided by 7 meter. Now let's see the distance covered in 40 seconds is equal to 4400 divided by 7 meter. In 40 seconds it completes one round, the person. So one round is equal to one circumference. So this is the distance covered in 40 seconds. Now we have to find the distance covered in 2 minutes 20 seconds, that is 140 seconds. So what we will do, we will multiply 140 into 4400 divided by 7 divided by 40. So let's solve it. That will be equal to 140 into 4400 divided by 7 into 1 by 40, and that will come out to be, if you will calculate it and cancel all the quantities, you will get it as 7 2s are 14 and 0 gets cancelled out, and 4 5s are 20. So you will get here 2200 meter. So this is one of the answers, that is the distance covered in 2 minutes 20 seconds is 2200 meter. Now what is the displacement? For that we will take out the number of rounds that has been covered in the given time. So number of rounds is equal to total time divided by time taken to complete the one round. That will come out to be 3.5 rounds. So that is 3.5 rounds. It means 3 complete rounds from A to A, from A to A, from A to A, and half round, that is from A to B. So ultimately the final position will be B and the initial position is A. So the displacement is between A and B, and A and B is our diameter. So the displacement will be equal to AB, which is equal to the diameter, and that is in turn equal to 200 meters. So this is our another answer. The distance covered in the given time and the displacement covered in the given time is 2200 meter and 200 meter respectively. Question number 2 is, Joseph jogs from one end of A to the other end of B of a straight 300 meter road in 2 minutes 30 seconds and then turns around and jog 100 meter back to point C in another 1 minute. What are Joseph's average speed and velocities in jogging from A to B and then from A to C? So again here we will first draw a diagram. So let's come here and we'll draw a diagram. We'll draw a straight line from A to B. That is, from A to B the total distance is 300 meter. Joseph jogs from A to B, that is 300. And now when he returns back to point C, that is 100 meter. So this distance is 300 meter A to B, and B to C is 100 meter. Okay. Now first let us calculate from A to B the speed and velocity. So from A to B, speed is equal to distance upon time. Total distance is 300 as you can see from the diagram, and total time taken was, you have been given the total time as 2 minutes 30 seconds, that is 2 into 60, 120 plus 30, that is 150 seconds. I will convert entire time into seconds and you will get as 150 seconds. So this will give you 2 as the answer. So the speed will be equal to 2 meter per second. Now next we come to the velocity, that is equal to displacement upon time. Now here displacement is also equal to distance only, that is 300, time is also same, that is 150. So again answer will be same, that is 2 meter per second. So here the speed and velocity are same. Now for the second part, that is from B to C. In case of BC, this is from A to B. Now from B to C, the speed is again equal to total distance upon total time. Here total distance is 300 plus 100, that is equal to 400. So 400 divided by 150 seconds already taken, and another it has returned in 1 minute from B to C. So 1 minute is equal to 60 seconds. So 150 plus 60, that is equal to 400 divided by 210, that will be equal to 40 divided by 21 meter per second. Next we come to the velocity. Velocity is equal to displacement upon time. So displacement here is 300 minus 100, because this is the initial, this is the final position. So 300 minus 100 is equal to 200. So 200 upon time will be same, that is 210. That will be equal to 20 upon 21 meter per second. You can convert into decimal also, and this is both the speed and velocity from A to B and B to C. Now we come to question number 3, that is Abdul, while driving to school, computes the average speed for his trip to be 20 km per hour, and on returning the speed is 30 km per hour. So you have to find the average speed of Abdul. So again I have drawn a diagram. From A to B the speed is 20 km per hour, and on returning 30 km per hour. You have to find the average speed. So first let the distance be x. From A to B let the distance be x kilometer, and the time taken from A to B, again we'll assume it as t1 seconds. Okay, so this is also we have let. Now t1 is equal to distance, that is x, upon time, that is 20. So that is t1, that is from A to B. And now from B to A, again in the similar manner, t2 will be, we will assume the time taken in returning will be t2, and it will be again equal to x, distance upon speed, that is 30. Now total time taken is equal to t1 plus t2, that is x upon 20 plus x upon 30. You will find the average LCM, you will take it as 60, that is 30 plus 20, that is 50x. That will be equal to 5x, and that will be equal to x upon 12. So this is total time. You can write it, the unit, as seconds. Now average speed is equal to total distance upon total time. Total distance is x plus x, because it has gone x distance, x kilometer, again come back at the same distance, so x upon x, and total time is, we have calculated just now, is x upon 12. So that will be equal to 2x into 12 upon x. Now when you will cancel it, you will get it as 24 km per hour. Now we come to question number 4. A motorboat starting from rest on a lake accelerates in a straight line at a constant rate of 3 meter per second square for 8 seconds. How far does the boat travel during this time? So this is a formula based question. Directly we will use the formula, that is S is equal to ut plus half AT square, in which you have been given time, you have been given acceleration, initial velocity is 0 because the motorboat has started from rest, and you have to find the distance. So u is 0 into time is 8, 0 into 8 plus half, acceleration has been given as 3 and time has been again given as 8, so 8 square. 0 into 8 will be equal to 0 plus half into 3 into 8 is 64. So 3 into 32, that is equal to 3 2 is 6 and 3 3 is 9, 96 meter, I think will be the answer. Yes, 96 meter is the answer. Okay. Next we come to question number 5. In which you have been given two cars A and B, both traveling at different speeds, and the time has been given after applying the brakes, in which they slow down and come to stop. So you have to plot the graph and you have to find out which of the two cars have traveled farther after the brakes were applied. So first let's come to car A. Answer number 5. For car A, we'll first find the speed in meter per second, initial speed. So initial speed, that is u1 for car A is equal to, the value has been given as 52 km per hour. So 52 into 5 by 18. So if you will calculate, you will get the answer as 14.44 meter per second. Okay. And the final speed, that is v1 is equal to 0 because it has come to stop. Now t1 is the time taken initially was 0 and the next time in which it comes to stop is given as 5 seconds. So you have got the values u1, v1, t1 and t2. Now for car B, again the initial speed, that is u1, will convert into meter per second, that is 3 has been given, 3 km per hour. So 3 into 5 by 18, you will get the answer as 0.83 meter per second. And here also the value of this is u2, let it be, and v2 is equal to, here be 0 because again it has come to stop. t1 was 0 and t2 again here was 10 seconds. Okay, now keeping these values, we will plot a graph. I am not exactly plotting a graph, I am just showing you how it will come out to be. We will take the time on x-axis. Here we will take the time as 0, 1, 2, 3. This is origin. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Till 10 you can take it here because we require only 10 here. And here we will find 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Equal distances will take 1 centimeter. 1 centimeter is equal to 1 unit on both x and y axes. Here we will take the speed on y axis. Here we will take the time. Now if you will plot for car A, you can see at time 0 you have the speed as 14.4. So one of the points will be somewhere here 14.4, and at t2 is equal to 5 seconds, the v2 is 0. So another point will be at 5, 3, 4, 5. Okay. Now we'll join these 2 points, and this is the graph for car A. Okay. Now similarly, when we'll plot the graph for car B, you can see at t1 0 the value is 0.83, so it will be somewhat here, and for value t2, that is 10 seconds, the v2 is 0. So here we will plot at 10, that is, this is the point. So this will be the graph somewhat for a triangle will be there. Okay, so this will be the graph for B. Now if you have to find the last part of the question, says that find out which of the two cars traveled farther, how much distance has been covered. So you have to find the area of these two triangles, half base into height for car A and half base into height for car B. So for car A, you will get The answer has half base into height, so you will calculate it. Base has been given as 5 and height is 14.4. And for car B, again half base into height, so half into 10 is the base and height is 0.83. Calculate it, and obviously you can see the difference in the graph, and from the graph only you can tell which car has traveled the maximum distance.